All right, we're back. Found the key. Here we go. Dead trees, Rocky Mountain National Park. Many mature pine trees along Highway 34 are dying due to infestation by pine beetles. It's like our gypsy moth caterpillars. Scientists would like to use a random sample of size 200 to estimate the proportion of approximately 5,000 pine trees along the highway that have been infested. Explain why it wouldn't be practical for science to use an SRS in this setting. Well, to have an SRS, you'd have to have all 5,000 trees numbered and labeled, and then you'd randomly choose 200 of them, and then you'd have to investigate, and it's just not a good use of your time. Who has time to go label 5,000 trees? Okay, so that's why it's not practical. Part B. A possible alternative would be to use the first 200 pine trees along the highway. Okay, so this is kind of like when I said the first 5 people that go to lunch. Is that a good way to do it? No, it's not. Okay, that's a convenience sample, so that's not a good idea. Describe how to select a systematic random sample of 200 pine trees across Highway 34. So if you have, let's look. We have 5,000 pine trees, okay? You want to choose 200 of them. So you need to find out, if it's systematic, how many you have to count out. So if you did 5,000 divided by 200, you get 25. So what you would do is count out every 25 trees. Still a task. Wow, still a task, but you'd have to count every 25th tree, and then look at the infestation and see what it's like. Okay? Number 2. Suppose 1,000 iPhones are produced at a factory today. Management would like to ensure that the phone's display screens meet the company's quality standards before shipping them to retail stores. Because it takes about 10 minutes to inspect an individual phone's display screen, managers decided to inspect a sample of 20 phones from the day's production. Explain why it would be difficult for managers to inspect an SRS of 20 phones that are produced today. Well, it's kind of the same idea, right? If you're trying to locate 20 phones among the 1,000 produced that day, assuming none of them can be shipped until after inspection, trying to get 20, okay, would be easier. Inspecting a random sample of 20 could delay the shipping process, okay? So that's why that's going to be harder. It's going to delay the process. So part B says, an eager employee suggests it'd be easy to inspect the last 20 phones that were produced. Why isn't this a good idea? What happens to you guys at the end of the day? You guys as sharp as you were at the beginning of the day? Well, guess what? People that make iPhones probably are not either. So by the end of the day, they might have had it, and you're not going to get probably a representative sample there. Describe how to select a systematic random sample. 20. You're choosing 20 out of 1,000. So that means you could select every 50th phone to check. All right? Good stuff right there. Good stuff. Hope it makes sense. Okay? I spent longer searching for the answer key as I read the questions and realized how easy it was. All right. So we go here to Hotel on the Beach. Okay? Hotel on the Beach. I'm going to do this one with you because I think this one's tough. Okay? I think it's one of the harder questions on there. It says, the manager of a beachfront hotel wants to survey guests in the hotel to estimate overall customer satisfaction. The hotel has 2 towers. Okay. So we go 2 towers. An older one to the south and a newer one. So let's say that's old and let's say that's new. Each tower has 10 floors of standard rooms. Okay. So 10 standard, and there's 40 rooms there, 10 standard, so that's 40. And then 2 floors of suites. Okay, and suites have 20 per floor. Half of the rooms in each tower face the beach. And half, face the parking lot? Face the street. Okay, this means there are 2 towers times 10 floors times 40 rooms plus 2 towers times 2 floors times 20 suites. 880 total rooms. Simple random sample of 88 rooms. Okay, so for each of these questions, pause, at least think about it. Okay, I want you to pause and think about what the answer would be, and then give it a shot. All right, and then I'm going to go over it. You can say, yeah, I was on the right track. You'd be like, yeah, no, I wasn't even close for that one. So pause, and we'll start off with simple random sample. Okay, I'll keep this close. SRS is first. Put it right here, I guess. We can put it right here. All right, so simple random sample. There's 880 rooms. So now, when we're talking about our sampling procedure, you're going to think this is foolish, but you have to really, really explain every piece of it. So I would not. This is what I would not do. Not. No. Okay, danger, danger. 1 to 880. Why wouldn't I say that? Anybody have any ideas? Well, it's because this has 1 digit and that has 3 digits. So the way you would say that is you would say, label each room 001 to 880. That's the correct way. And if you say this, it's going to be wrong. Okay? You have to have the correct number of digits. We need 3 digits for this job. Okay? So you have to start off with 001 to 880. So you label each room from 001 to 880. And then use a random number generator to select 88. That's what we're selecting, right? We're selecting 88 unique rooms, or 88 rooms without repeats. You have to say that in there. You have to have the part about no repeats. Okay, it's very important. All right, so that's part A. That's part A. We did the simple random sample. Now, part B. We want stratified. Okay, so I'm going to let you guys pause that one. All right, and think about how we could stratify here. How can I stratify here? All right, so we have to decide between the north and the south. We have to select 88 rooms, man. Well, let's look. So here, let's look at what we have. So each of the towers has 10 floors of standard rooms, 40 rooms per floor. So I think that's what, 400? Okay, so each tower has 400 rooms. So the old tower has 200 and 200 and 200 and 200, because I think some of these are going to be beach and some of these are going to be street. So you have the ones that face the beach and one that's face the street. Okay? And then you also have suites. Okay? And in the suites, you're going to have 2 floors of suites that have 20 suites per floor. So what's that going to be? 2 times, we said this one was 10 times 40, which is 400. So this is going to be 2 times 20, which is 40. Okay, so you're going to have 20 that face the beach and 20 that face the street. And if you notice, I separated these at the beginning, the old and the new, because when you look at it, let's face it, everyone wants to be in a newer hotel. Some of those older hotels are going to be lousy. So let's look. Ready? So we got to select 880. So I could do 20, 20, 20, and 20. That's 80, and then 2, 2, 2, and 2. Okay? 20 out of 200 is what, 10%? And then 2 out of 20 is also 10%. So we're going to take 20 from the old tower that face the beach. Okay? You're going to take 20 from the old tower that faces the street. And then you're going to choose 2 from the old tower. Okay? 2 from the old tower. Just making sure I'm recording. That's the beach. and then 2 from the old tower that faces the street. Okay, and now we're going to do the same thing for the other side. Okay, so it's going to be 20, 20, 2, and 2. And I think that's going to give us our 880, right? Or I'm sorry, not our 880, our 88, excuse me, our 88. Okay, and this is going to be from the new tower, and then the rest of the information is the same. Okay, so part C, explain why selecting 2 of the different floors would not be a good way to obtain a cluster sample. So it'd be easy to collect that way because you only have to go to 2 floors, but you know, the floors need to have a good mix of all the types of rooms if you're going to select them. If you selected someone and they all had suites, they might have a better opinion of this hotel than someone that's on a standard room. Okay, so I think that a cluster sample would be mixing them up first. Okay, so that they all have a good mix of the rooms, not just suites or not just standard rooms. Okay, man, we are struggling through this section, aren't we, guys? All right, so advantages and disadvantages of each sampling method. So an SRS is simple, it's easy to execute, okay? Everyone has the same chance to be selected, but there's a chance that some groups will be overrepresented, so that's not good. Stratified is a little more complicated, but there's no chance that groups will be over or underrepresented, okay? You're gonna get some freshmen, some sophomores, like that example that we talked about. Cluster samples, very convenient, okay? Each group is equally represented, but some patterns could lead to over or under representation. It could, okay? So, inference for sampling. Inference for sampling as we limp to the finish line. I'm intimidated by how much more we have in this section. Intimidated, but we can do this. All right, inference for sampling. Inference, the whole part of this is doing inference. We're trying to find out what's true, what's happening here, and we're using a sample to get us there. We're using a sample to get us home. We're inferring about the population, the information that we obtain when we get the sample, okay? Inference from convenience samples or voluntary response samples are misleading. The methods are biased. When you have bias, it's misleading. We're almost certain the sample doesn't fairly represent the population, okay? Now, it's still it's unlikely results from a random sample are exactly the same. You're not going to get exactly the same. You're trying to get an idea. You're trying to get an idea. Okay? Properly designed samples avoid bias, but are rarely exactly correct. We expect there to be some changes. We expect them to vary from time to time. Okay? Larger samples give better information. I can tell you that. Okay? Now, results from random samples come with a margin of error. If you're watching the news, if you're even remotely interested in watching the presidential stuff, you'll see that the surveys and the polls that they take always come with a margin of error. It has it right on there. It'll say, you know, this comes, wow, it is windy out there. It comes with a, I don't know, a margin of error, plus or minus 3 or 4%. Okay, it's like hurricane force winds, right? You guys don't believe me. Ready? Watch this. Look out there. It's October right now. It's October. When I'm filming this, it's October 7th. Okay? Let me see if are you guys still in the window? Wow, I'm like Annie M out there. Yeah, it didn't work out too well, did it? And my battery's running low, guys. Boy, we're having some troubles today. I'm going to try to get this back. I wanted to show you guys the wind. You can hear it. You can hear the wind. I got to cook out in that wind a little bit. We'll see. All right, guys. I'm losing my I'm losing the battery power, so I'm going to change the battery and I'll be back.